Hello, everyone. Welcome to the fourth webinar in a series of quality-related webinars presented by the MPIA Quality Alliance, a subcommittee of the Montana Photonics Industry Alliance in Bozeman, Montana. Thank you for joining us. My name is Ben Klein. I'm the quality manager for Teledyne FLIR Surveillance Incorporated here in Bozeman, Montana. The subject of this webinar is the discrepant material process. This is one of the most critical processes to manufacturing flow. In this presentation, you'll learn what a discrepant material process is, why it is so valuable to the flow of manufacturing, a few easy steps for how to implement this process in your organization, and how the discrepant material process leads to improving your system. So what is a discrepant material process? Imagine a race car getting a flat during a race. It pulls off the track into the pit stop. The pit crew quickly removes the wheel with the flat tire and places a new wheel with a fresh tire on the vehicle, gets the vehicle and driver back on the track. The pit crew then studies the flat tire to try to figure out why it happened, that is, what might have caused the flat, and then tries to determine what to do with the flat tire. Do we remove the tire from the rim and put a new one on? Patch the tire and try to use it again? Scrap both the tire and the rim? Maybe the rim is damaged. Meanwhile, the car is still in the race. This is the discrepant material process. It is a process for managing discrepant material to minimize the impact to the flow of manufacturing. Discrepant material can occur anywhere in a manufacturing process, but generally it occurs during incoming inspection, assembly, or testing. And just as a flat tire can affect the performance and outcome of a race, the discrepant material can interfere with the performance and outcome of manufacturing. So let's talk about what we mean when we say discrepant material. Generally, what we mean when we talk about discrepant material is that it's non-conforming. It's non-conforming, meaning it does not meet specification as defined by a drawing or print. For example, a chip on a scratch in an optic that doesn't meet surface quality spec, dimensions on metal parts that don't meet spec, or failed PCB. However, it can also mean material or parts or components that are questionable in some manner. Two conforming parts that don't fit together due to tolerance stack-up is discrepant. For example, a scenario where an optic doesn't fit in the housing, even though the dimensions for both parts are in spec. Or you notice that a coating on a batch of optics you just purchased has a different color, a slightly different tint than what you're used to seeing. All of these are considered discrepant material events. And discrepant material includes parts or material you've purchased, subassemblies you're trying to build, or even final product that fails during final acceptance testing. In a complex, sensitive, nonlinear, high-fluence photonics product, it's a good idea to question non-conforming or questionable material and set them aside for further evaluation rather than risk using them in your product. So why is the discrepant material process invaluable to manufacturing flow? Even if you've developed the most effective processes and documented them as clearly as possible, have a low-risk, elegant design with highly tuned tolerances, well-trained, skillful technicians with a keen sense of detail and curiosity, a trusted partnership with top-notch suppliers, you will encounter discrepant material. Therefore, it is essential to design and implement a good process for managing discrepant material. This is essentially a solution to a problem you will face while manufacturing your product. The discrepant material process is invaluable to manufacturing because it improves efficiency, mitigates risks, and serves as a vehicle for communication. A good discrepant material process improves the efficiency of manufacturing process because it quickly removes and replaces discrepant material so you can keep manufacturing flowing rather than spending time trying to fix a bad part. In the race car analogy, you don't want your driver to step out of the race and begin trying to fix the flat, trying to figure out why it became flat, and then spending valuable time looking for a replacement, all while the race is going on. The same is true for your technicians. Discrepant material is purely an obstacle. It interferes with the ability to perform the key function of assembly. So it improves the efficiency because it quickly removes the discrepant part from the manufacturing flow, prevents wasted time through rework on the fly, and quickly replaces discrepant material with new material so assembly can continue. The discrepant material process also mitigates risk. If you prevent the material from being accidentally incorporated into other products, which could cause additional problems, possibly bigger problems later in the assembly process. It reduces the risk to the cost of material and labor. If a technician has to spend time trying to fix a part before they use it, then your labor costs will increase. If you have to continuously replace parts, your material costs increase. In either case, the cost of your product increases and decreases your margin. It reduces the risk to the production and delivery schedules. Time spent trying to fix a bad part or trying to find a good part is time not spent building to schedule. And finally, it reduces the risk of a bad product reaching the customer, resulting in returns. Now, generally speaking, a bad part will prevent your product from working before you even ship it to the customer. However, a bad part may result in latent failures of your product once it's in the field, in use with your customers, and this can have a huge impact to your reputation. The discrepant material process serves as a vehicle for communication that a new part is needed. If the discrepant material is discovered during incoming inspection, then you can use it to communicate to the vendor that there is an issue with their part. If the discrepant material occurs during assembly, then it notifies the stockroom the replacement is needed. Now the stockroom can update the inventory count and can replenish inventory. If the discrepant material is significant enough, you may want to communicate to the customer that delivery schedules may be at risk. The discrepant material process improves efficiency, mitigates risk, and facilitates communication. Implementing a discrepant material process is fairly straightforward. Now, there are many solutions to solve this problem, to how to manage discrepant material, but most of them you'll find have some common approaches or at least some similar steps. The solution that we're going to show you here today hopefully will give you what you're looking for, or at least give you some ideas for how to implement a process best suited for your organization. And as you will see with the solution we are providing in this presentation, you can use basic low-cost tools that are likely already at your disposal that are quite effective. So the overview of this process can be broken down into three primary top-level steps. And these steps are probably going to be pretty common to any organization. The top level are pretty common. So we'll talk about these and then we'll go into detail in the following slides. So the first step is to identify and document your discrepant material. The second is to evaluate the information regarding the discrepancy to determine disposition. And finally, to perform the disposition. Identify and document. The first step when you encounter discrepant material is to identify it in some manner as discrepant using a label or a tag. The next step is to document key information about the discrepant material event. This includes basic information such as part number, serial number if it has one, the date, your name, but it also includes sufficient description of the discrepancy and the nature of the discrepancy, such as key factors and conditions in which it occurred. For example, you may write, there was a large scratch on the optic well within the clear aperture that occurred while trying to place it in the housing. The best way to capture this information is on a form. This form is called the Discrepant Material Report, or a DMR. The information from the DMR is then logged in a spreadsheet or database. We call this the DMR log. Each entry has a DMR number to uniquely identify the DMR event. You'll see later how capturing and compiling this information can lead to improving your system. This log also serves the key function of tracking the discrepant material throughout the process so it isn't lost or forgotten. Finally, the log serves as a history to help you determine what to do with the part based on what you did the last time you encountered the same situation. Tools and equipment. Labeling or tagging a discrepant part may not be possible if the parts are too small or delicate. So here is a solution that you can consider. If you can't tag the part, tag a bag and put the part in the bag. Label the bag with a sticker that states reject or discrepant. This identifies the part as being no good. You could have a stack of these bags next to where you work so that they're easily accessible. After you've completed a DMR form, you can place it in the bag with the part. Now the part is clearly identified as discrepant. You know exactly what the part is, and it has the associated information that will make it easier for those who have to evaluate it. Place the bag with the part and the DMR into a clearly marked bin. This bin ensures that the part is segregated away from good parts. The bin can collect all of the bad parts and be presented to the evaluation step of the process. The purpose of the evaluation step is to determine the disposition of the material, that is, what to do with the material based on the information provided on the DMR. Disposition is generally determined based on risk to the quality and reliability of the final product. But it must also take into account several other factors such as risk to schedule and cost. Evaluation is generally done by a group of people with knowledge, experience, and expertise to assess these risks. This group can include representatives from manufacturing, engineering, materials, purchasing, quality. We call this group the Material Review Board. The evaluation by MRB can occur formally by meeting regularly, say once a week, to review the discrepant material in the bins and prepare them for disposition. But this can also be done more informally on the fly based on the urgency and risks. In any case, the disposition of the material also gets documented in the DMR log. This also indicates that it has passed through this fundamental step. Disposition. The final step in the process is to perform the disposition. And this is based on the decisions made by your Material Review Board, your MRB. Disposition generally falls into one of four categories. Use as is, that is, return it to stock or back to the floor so it can be used again. Rework or repair, initiate rework to rework or repair the item. Return it to supplier, send it back to your supplier so they can assess it and then rework, repair, or replace as necessary. Scrap, throw it away, or destroy it in some manner. So 3 easy steps. Identify and document, evaluate to determine disposition, and then perform the disposition. Improvement through data. Finally, the discrepant material process is invaluable to manufacturing because it can help you improve your system. Because you've logged the discrepant material in your DMR log, The information can be compiled and analyzed for patterns and trends. Generally, this takes place in the form of a Pareto chart. The x-axis is generally organized by part number. The y-axis is based on the discrepant items, the number of discrepant material events, or the highest cost. But one great way to evaluate it is based on the greatest impact or risk to manufacturing flow. A few 10-cent screws might not show up on the front end of the Pareto chart for quantity or cost, but this could result in the high impact if it shuts down manufacturing. These Pareto charts give insight into which parts are failing the most, which failed parts are causing the biggest impact to schedule or cost to the organization, or which suppliers are providing the most discrepant parts. In this case, the log actually and the analysis that you're performing can be used as a supplier performance metric as well. The Pareto chart gives direction for where to apply your resources to perform root cause analysis and ultimately to initiate improvement to your system. For example, in the race car analogy, if your front right tire becomes flat more often than any other tire, you know where to focus your attention. Generally, you'll find that you will improve your system in three primary areas. You can group these into three areas: process, design, and supplier. If the cause of the problem is your process or your methods or your tools, then you'll want to revise your work instructions, your procedures, your forms, your tools, fixtures. It can also include training personnel to be sure the current processes are understood or simply to continue to develop their skills and knowledge. Your personnel are key parts of the success of that process. If the cause of the problem is the design, you can work with engineering to improve the design to make it more manufacturable. Maybe the tolerances are too tight, or the notes on the drawing are ambiguous or confusing. Having engineering improve the design will not only improve the manufacturability of your current products, it can provide invaluable lessons learned for future product designs. If you determine the cause of the problem is the responsibility of the supplier, you can begin working with the supplier so they can improve their processes. Or this could serve as another mechanism to improve your design so the supplier can more easily make your parts. By working with your suppliers, you have the added benefit and opportunity to build better relationships with them. So summary, this is what you learned about the DMR process. The discrepant material process is the process for managing discrepant material throughout manufacturing. The discrepant material process improves the efficiency of manufacturing, reduces risk, and serves as a vehicle of communication. The discrepant material process can easily be implemented in your organization using basic low-cost tools. The discrepant material process provides data that can be used to improve your system. Implement this process in your system and help your organization take another step on the path of success. For more information about this process, example templates, tools, and ideas, please visit our website at montanaphotonics.org. Thank you so much for your time.